Recording in progress.
In this video, we'll talk about Kirchhoff's law, and then we'll do examples and solutions based on Kirchhoff's law. I'm going to show you how to use Kirchhoff's law, and I'm going to explain some of the important keywords for Kirchhoff's law and what you need to know and what you can use to answer questions regarding Kirchhoff's law. Before you start deriving formulas using for Kirchhoff, in the circuit, we're given two loops. And then on the middle we have a resistor which is called R3 with the value is 390 and R2 is 220, R1 is 470. So we are given a direction. We're told or direction for loop 1, the current is going to enter the junction, and both directions, they're going to meet on this junction. Someone may ask why the direction of a current, why these directions they are going in this way, and why this one is also coming in this way. That is because a current moves from a higher potential to a lower potential. If you want to determine a direction of a current, you must always start from positive to negative. A current moves from positive to negative, always. So now we want to derive a formula we want to know what is R3, what is I3, the current that will flow through the 390 ohm resistor. We are going to use a KCL, a Kirchhoff's current law. A Kirchhoff current law states that I in is equal to I out. That means the current that is entering a junction is equal to the current that is leaving a junction. So let me redraw that junction there. So we have I1 is entering this junction, and I2 is also entering this junction, and I3 is leaving a junction. So that means the sum of I1 and I2 is equal to I3. Why? Because I1, I2, they're doing what? They're entering a junction, and I3 is the one that is leaving a junction. So formula for current I3 is equal to I1 plus I2. Why I'm doing this is because when I want to derive equation for loop 1 and for loop 2, I don't want to use I3 because I will have 3 unknowns. So I want to use I1 plus I2 to replace I3 with. I'm going to replace I3 with I1 plus I2. So now let's derive equation for this circuit, and let's see how can we get the current for loop 1 and for loop 2 using Kirchhoff's law. So Kirchhoff's law starts here by using this theory of I1, I in is equal to I out. So now we want to determine the current I1, I2, I3. For I1 is the current in loop 1, I2 is the current in loop 2, I3 is the current through 390, which is the resistor in the middle. So Kirchhoff's law, we apply it or we use it when we're given a circuit and the circuit has more than two suppliers, or voltage sources. We can use a Kirchhoff's law to get our current and voltage across the loads. It's easy when we use Kirchhoff's. So we can also use Thevenin method. I'll show you. Using Thevenin method in another video. So now let's derive equation for loop 1. So we're going to apply KVL. So for KVL is that the voltage across the nodes is that the V in minus the voltage across the nodes, they're equal to 0. Meaning what is the V supply minus the voltage across your loads is equal to 0. That KVL, which is Kirchhoff voltage law. But I'm not going to use that one. Let me show you the easiest way to get equation for loop 1, to derive formula for loop 1. So now I want to derive a formula for loop 1. First, check whether your voltage source is in the same direction with the direction that you're given in that loop. So now in this loop, our direction is going up. And then the battery, its direction, when we draw it from positive to negative, it also going up. So meaning that voltage is positive. Sometimes you'll find our voltage is negative. So here it's going to be positive. Why? Because it's in same direction with our direction that is given in the loop. So I will say 9 is equals to, since this is positive, so 9 is equals to, a voltage or a V source or a V supply, it's equals to the sum of the voltages across your loads. I have 9 volts, is supplying 470 and 390. That means the voltage across 390 plus the voltage across 470 is equals to 9 volts. Simple. So I will simply say VR1 plus VR3. That's how I'm going to derive equation for loop 1. So 9 is equals to, let me simplify. Remember, I want to work with currents. I want to simplify. So what is VR1? VR1 is I1 times 470. I have the value of the resistance. So I will simply replace the resistance with its value times 470 plus VR3. VR3 is the current across that resistor times its resistance. So what is VR3? VR3 is 390 times I1 plus I2. I1 plus I2, which is I3. Here's the formula for I1 plus I2. My main formula for I3 is I1 plus I2. So now this is the equation for loop 1. So let me simplify it further. So meaning, since I have I1 times 470, and if I remove the brackets through I1 plus I2, I'm going to get 470 I1, 390 I1. So I can add both I1 of 470 and I1 of 390, since the variables are the same, which is I1. So I will have 470 I1 plus 390 I1 plus 390 I2. So now on this equation, since I have I1, the variables are the same, meaning I can add them. I can add 470 and 390. 470 plus 390 is equals to 860. Is equals to 860. I1 plus 390 I2. So this is equation 1 for loop 1. So that's how we derive the formulas. So let's derive another equation for loop 2. So for loop 2, I want to derive equation as well. So since it's 12 volts, I will use the same method to derive the formulas. So I will say 12 volts is equals to VR3 plus VR2. 12 is equals to, what is VR3? VR3 is I1 plus I2 times 390 multiplied by 390 plus VR2. VR2 is I2 times 220. So simplify further, is 390 I1 plus 390 I2 plus 220 I2. Then I can simplify it further. Since I have same variables, I have I2 plus I2, they're the same variables, I can add them. You can add them only if the variables are the same. of your current. So since I have I2 here, I2, I can add the values, whereby it's 390 plus 220 is equals to 610. So why is my voltage source positive? We don't just put 12, positive 12. We check whether if our bedroom is placed and its direction is the same direction of the direction in that loop. So direction in our loop is going to the left. So let's see our direction from the battery. Remember, direction will always start from positive to negative. That's the direction of a current. So for 12 volts, the direction will start from positive to negative. So it's going to start from right to left. So the directions are the same. So we put positive voltage. If the directions are not the same, we put a negative voltage. So now I have equation for loop 1 and for loop 2. I want to determine I1 and I2. Then from there, I will determine I3. So I'm going to use a matrices to get I1 and I2. I'm going to use matrices to get I1 and I2. So to get I1 and I2, I'm going to use matrices. I have two equations. I can use 2 by 2 matrices. I'm going to use 2 by 2 matrices. From loop 1, I'm going to put loop 1 here and loop 2 in respectively. So I will start with 860 and 390. 390 again and 610. Then I will put I1 as my variables. Here is 9 volts and 12 volts. From there, you can use your calculator. You can use a calculator to get the values using matrices. Please use engineering calculator, FX991ZA plus. Use that calculator to get I1 and I2. So I'm going to use matrices to get the I1 and I2 values because it's simple. I'll just use a calculator to get the values. Please make sure you buy a Casio engineering notation FX99 and 1ZA plus calculator. That one you can use it to get the values using matrices. We'll have a video based on matrices, how to use the matrices, and then how to get the values of matrices, determinant, and whatsoever. So now I1 is equals to 2.174 milliamperes. Then I2 is equals to 18.282 milliamperes. So now that's the current for I1 and I2. Then to get I3, I have that formula. I3 is equals to I1 plus I2, 2.174 plus milliamperes, milliamperes plus 18.282 milliamperes. So I3 is equals to 2.174 plus 18.282. So I3 is equals to 20.456 milliamperes. That is I3. So someone will ask me, how did I use a calculator? So to use the calculator, we first derive the formula for loop 1 and loop 2. Then you place it in a matrix form. This is a matrix form, the one with square brackets. So you place it in a matrix form. So now you want to get the values using a calculator. The calculator that can do that is engineering calculator. The code is FX991ZA plus. So now I will explain on how to use the calculator to get the values. You press mode on the calculator and press 5 and press number 1. Then you will see a square brackets with A, B, C on top and 1, 2. 1, 2 determine means is 2 rows. Is 2 rows and then with 2 columns, which is 2 by 2 matrices. So you place the numbers for you're going to start from row 1. You're going to enter 860 and you say equals to. You enter 390, press equals to, enter 9, press equal sign. It's going to take you to after placing or entering or recording the numbers on row 1, it will take you to row 2. So you will press 390, press equal sign, 610 equal sign, and 12 equal sign. Then you press equals to. It's going to give you x. X is for I1, which is the current that I wrote there. And the press gives you y. Y is current for I2. Then from there, you add the current, they will give you I3. So that's how we use Kirchhoff and matrices. So then the matrices size is determined by the loops of your circuit. So we have 2 loops. We're going to use 2 by 2 matrices. If it was 3 loops, 3 by 3 matrices, and so on. So this example, and here is the solution on how to get I1 and I2 using Kirchhoff's law. So let's go to the next question. Here's another example. Sorry. Here's another example. We have a 2 loop circuit. Now the battery and the resistor on the middle. We have a resistor there, resistor, and the supply. So let me just write positive, negative, positive, negative. So the question, the same question, find I1, determine I1, I2, and I3. I3 always is the current in the middle. Then I1 is the one in the loop, in loop 1. Current I1 is the current in loop 1, which is LP1, and I2 is current in LP2, which is loop 2. So before we derive the formula, let's get the current through our middle resistor. So through the middle resistor, the current in loop 1 is going in this in that direction, because the direction of the current is determined by the direction of the loop. So this direction in this loop, this direction we are given, is the one that will determine the direction of the current. So now if the current is going in this way, and then also the direction in loop 2 is going in that way, so meaning what will happen for the current through the middle resistor? It will go down. Why it's going down is because of this direction. See, the direction that you are given is this direction. It can only it's like that. It's like that. It's the direction that you are given for both loops. It's the same direction. So to determine the current through middle resistor, we first draw direction of our currents through that junction. So now using that scenario of I in is equals to I out. I in is equals to I out. I1 is going to enter a junction, and I2 and I3, they will leave that junction. So let's determine the equation for I3. So that means I1 is equals to I2 plus I3. Why? I in is equals to I out. We're using Kirchhoff's law, guys. Kirchhoff's current law states that the current that is entering a junction is equal to the current that is leaving a junction. So I in is equal to I out. So in this junction, or on that junction, in this junction, I1 is entering this junction. And then I3 with I2, they are both leaving what? That junction. So that means the sum of I2 and I3, they're equal to I1. Because Kirchhoff's current law states that I in is equals to I out. So now we can start deriving equations for loop 1 and for loop 2. KVL. We use KVL to determine that. We use KVL. We use KCL to determine the equation for I3 or current formulas. So for loop 1 to derive the equation, we will first check our V source. Our V source, the positive, negative. To determine whether the V source is positive or negative, we check its direction. Its direction will start from positive to negative. So we'll start from positive and start drawing our direction from positive, meaning that direction. That means direction.
In progress.
Yeah, I was on direction for 20 volts. So 20 for this V source, to check whether it's positive or negative, we will start from positive and go to our right side. Then that means, or we just start from positive or go up, just go up. Then from there, we are given a direction in loop 1. So in loop 1, the direction you can see is also going up because it's going to the right side. So now we can derive the formula for loop 1. Going to the 20 volts, it's equals to V, I will call this R1. I will call 220 R1 is equals to I1 220 ohm plus 120 ohm. Oh, sorry. I will explain that. 120 ohm. 120 ohm I1 minus I2. Since in loop 1 we have 20 volts and 12 volts. So let's determine the voltage, the specific voltage for loop 1. 20 volts is positive. Why is positive? Because the direction of 20 volts is the same as direction that we are given in loop 1. So the 12 volts direction is going up, is going to the left, and the direction that we are given in loop 1 is going to the right. So meaning it's opposite to each other. So that's why we'll make 12 volts negative. It's going to be negative because its direction is opposite to the direction of that loop. So then we'll say 20 minus 12. Therefore, I1 times 220 is the voltage across 220. I1 minus I2 times 120 is the voltage across 120. The sum of the voltages in this loop, they are equal to V source, which is 20 volts. Therefore, 20 minus 12 is 8, equals to 220 multiplied by I1 plus 120 times I1 minus 120 multiplied by I2. Then the formula for loop 1 going to be 340 I1 minus 120 I2. That's the formula for loop 1. Therefore, the formula for loop 2 is going to be, so we'll first determine or check whether the V source is going to be positive or negative. Now, for loop 2, we're going to consider loop 2. The voltage is also in loop 2 and loop 1. Remember, the voltage is common on these two loops. So since it's in loop 2 and loop 1, for loop 1, we focus in loop 1. For loop 2, we focus in loop 2. Now we want to determine a formula for, equation for loop 2. We'll check the V source, and then we'll consider the direction in loop 2. we forget about the loop 1 direction. So we'll check the direction in loop 2 and we'll draw a direction from our V source in respective of loop 2. So if we check loop 2, the voltage source is the current will go up. And then actually you will start from positive to negative. If you draw direction, it's going to right side. And if you check direction in loop 2, it's going to the right side. Then that will make our V source positive. Then the equation will be like this. 12 volts is equals to 560 I2 plus 470 I2 plus 120 I1 minus I2. Therefore, the equation is going to be the equation minus 120 I1 plus 1030 I2. Therefore, we're going to use a matrix to get I1, I2. From there, we're going to substitute them to get I3. So for row 1 is 3. For loop 1, it's going to be the equation for loop 1. The equation for loop 1 is going to be our row 1 for the matrix. And the equation in loop 2 is going to be our row 2 in the matrix format. Therefore, 340 minus 120 minus 120 1030 I1 I2 is equals to 212. Therefore, use a calculator to get I1 and I2. I1 is going to be 28,826 milliamperes. I3 15.0 milliamperes. I mean I2. Therefore, I3 is equals to I1 minus I2. 28.826 milliamperes minus 15 milliamperes. I3 is equals to 28.826 minus 15. I3 is equals to 13.826 milliamperes. Then that's how we use Kirchhoff to get a current in loop 1 and loop 2.